Good morning, everyone. Good afternoon for those who are not in our same time zone. And as Kara mentioned at the beginning of our meeting, happy International Women's Day. And today we have, again, our joint meeting between the Standards Working Group and the testing centers. For today, we're going to have a few presenters. I'm really excited to introduce you to some of our new members. But first, we're going to start with some quick updates from ISWP, from Alex and Dr. Perman, as well as from Jack from the University of Pittsburgh. And then we're going to introduce you to Daniel Umaña from Colombia, from CIREC, and then Nargess Matinazad from PAConsult from Germany. And we're also going to hear from Tom Doyen from DECA. And we're going to wrap it up with some group updates. So if you want to start, Alex, please feel free.
Super. Hello, everyone. I see some new faces here today that I haven't seen before. So greetings to everyone. My name is Alex Carmadou. I'm the new Executive Director of ISWP. I'm an occupational therapist by background, and I'm based in South Africa, in Johannesburg. And I've been in this position for the last 4 months or so. So as everybody has articulated earlier, happy International Women's Day to all the women who've made a positive influence or impact in our lives. I think it's really important to reflect on that and really spend time to appreciate the women in our lives. I'm going to give you a quick update about the position of ISWP and where we are to date. We've had a lot of good news stories that have been happening, notwithstanding one that I'm now in position. But we've now onboarded Kritika Kandaval as our program manager. So we have now, the team is starting to grow. We've also managed to secure a decent grant from USAID through UNOPS, which will help with the operating costs of the organization as we move forward as a new entity. As all of you know, ISWP was incubated under the University of Pittsburgh and is now, or has now, transitioned to being a standalone and not-for-profit entity. And I'm pleased to say, yes, we have secured some funding, but we are looking at some other income streams in order to try and sustain the organization moving forward. So some of the updates from our organization, there's a lot of stakeholder management that has been going on. We had a meeting with Gato yesterday, and I'm delighted to say that we are going to be joining them as an affiliate member. There are some administrative requirements that we do not fulfill at the moment, which we need to go through before we become a full member of Gato. We also joined the workforce workstream of the World Rehabilitation Alliance, which is a network hosted by the WHO. And the goal of this is to advocate and try and deliver on the goals of the Rehabilitation 2030 strategy. We're in the process of just finalizing our sub-award to the University of Pittsburgh in terms of supporting the new entity as we transition across to its standalone entity. So for those who do not know, and to give you some background, ISWP has done, or the University of Pittsburgh has done, a fantastic job of incubating the organization, and we are now moving into that transition phase where we've got to move the founding board into its own standalone board. We've got to make sure that there's enough finances in order to sustain the organization. We've got to make sure all the governance and due diligence processes are in place, as well as setting up all the standing operating procedures and governance for any entity operating in this space. Coupled with that, we've got to do all the usual stakeholder management and being able to network and build consensus and build relationships with all the other international organizations. So when I mentioned about Gato, we're also in discussion with WHO about becoming a strategic partner for them as well. But at the same time, we also have to have business as usual and make sure that all the trainings, the product standards, and all the other great pieces of work that has been started continues as well. So just in terms of the trainings, we've had quite a few requests for some trainings in the Philippines, in Ghana, in Cambodia, and Kritika's working with myself to cost this up and to be able to provide people with the various packages of training. As you know, we have the basic, the intermediate, the trainer certification and the training of trainer training that is available through ISWP, as well as the various certifications. So there's quite a bit of work we're doing in terms of managing those various requests and being able to respond to those requests for training. We also conducted in December training in Laos, where we had 14 participants who did the intermediate and the training of trainers training, which was very successful. And we are looking at more training to provide in this particular field as well. I'm also pleased to say that as part of this whole initiative of becoming self-sustaining and looking at other income streams, ISWP responded to a WHO request for proposals in Egypt, which is about strengthening wheelchair provision across the whole health system in Egypt. This is made up of some training that will be done at a high national level and building the whole integrating of wheelchair provision into universal health coverage, which the country is moving towards. His Excellency is very much in favor of making sure that rehabilitation and wheelchair provision and prosthetics and orthotics is given a high profile within the country. And so we put in a proposal, so we're waiting to hear about that. Within the African Community of Assistive Technology, ACAT, we are delivering a webinar on ISWP and the value proposition. So with me being based in South Africa, I was very keen to build the relationships on the continent. And we reached out to the African Community of Assistive Technology, who were very keen to hear more about what we're doing. We've already had a really good relationship, but I think it was very timely for us to sort of say, ISWP is now relaunching, and we have all these opportunities to increase training across the continent and indeed across the globe. Another area that we're working in is the basic test 2.0. We are calling it version 2.0. This has been running for quite some weeks now, and we have about 80 participants that have actually taken the basic test. We've actually taken each of the modules and reviewed them to make sure that the domains and the questions are fit for purpose. And so we're doing a very comprehensive exercise to refine and make sure that the questions in the basic test are fit for purpose. So this process of piloting the basic test will end around the end of this month, at which point our data analyst will look at how difficult or how easy the questions were and then refine them. And we will go through another version of the basic test as well. So a lot of work happening in terms of getting that basic test finalized, and we will keep you posted about that. We also submitted a paper for the World Federation of Occupational Therapy Bulletin. This was in conjunction with Dr. Hassan in Saudi Arabia. And the title of the paper was A Perspective on Occupational Therapy and Assistive Technology, the Research, Contributions, Challenges, and Global Initiatives. We're still waiting to hear back from WIFIT to see if that was accepted. And it would be a really great new piece of work to showcase that the collaboration that ISWP has done in this space. Looking forward, there are a lot of conferences that are coming up, as many of you are aware of. We have a presence at ISS, at ISPO, both in April, where we will be presenting some of the great research that has been done. We will also be taking part in some of the panel discussions as well. Of particular note, at ISPO in Mexico, myself and Dr. Perlman will be part of the team that will be launching the much awaited wheelchair service guidelines that were co-created by ISWP, WHO, and other partners. So we're really looking forward to that event. We're also going to have a presence at World Physiotherapy in Dubai in June. And both myself and David Constantine, our chair, will be co-presenting the plenary session at the Posture Mobility Group in the UK in July. Also in July, some of the team members will be presenting at RESNA on best practices for wheelchair services. Yeah, so I think that is pretty much a very quick whistle-stop overview of what we've been getting up to in the first quarter, or very much the first 2 months and a bit of this year. And I will hand over to Dr. Perlman.
Thanks, Alex. So yeah, I think I've been prepping this group for the last maybe 2 years for the eventuality of a shift of the organization outside of Pitt. And so finally it's happened, and it took longer than we anticipated, but I think it was done in a diligent way. We ultimately had an external search firm lead the search for the executive director. It yielded over 80 applicants, and Alex stood out among many very qualified individuals, and in part because he has a clinical background as an occupational therapist, and also he's worked in the area of health system strengthening. And so many of the groups that we have collaborated with throughout the wheelchair sector have focused on more charitable operations to support different projects, and throughout many countries often. And there is a shift at hand, and I think it's a really great, the timing is right to start to compel governments to provide benefits for not only the products, but also the services associated with appropriate wheelchair provision. And so we think Alex came across, Alex did come across as somebody who had an excellent clinical background in terms of as a therapist and running wheelchair services, but also in terms of driving health system change to adopt and improve the benefit structure for wheelchair users. So we're excited. Alex has been ramping up. There's been a lot of behind the scenes work that Nancy Augustine has led, like she has throughout the entirety of this project, to try to set up the separate entity, make sure we have things like bank accounts and addresses, and can pay people like Alex and Krithika. So it's been quite a lift to get it going, but it is now fully going and funded. And over the next year, as Alex mentioned, the university is going to stay engaged and support activities, I think, in 3 different pillars. One is the administrative activities that Nancy will continue to be involved in. And then these 2 main pillars that ISWP works on right now, which are advancing product and service standards in the wheelchair sector. Alex talked a lot about the great work that's going on in the training side, and that's advancing the service standards by building capacity for workforce around the world. And it's been an impressive growth in over 100 countries with thousands of people trained by now. And that just keeps on moving forward. This group has been instrumental, as you all know, for now, and some that are on here have been here from the very beginning. I see Eric and Don being sort of some of the founding members of this group. And what we've done is quite amazing in the product standard side. We've gone all the way from, doing a good bit of research and publishing and building some evidence related to what's happening to wheelchairs out in the field, to developing test methods, including those that have been adopted by ISO, providing some great guidance documents, either through the wiki and through design considerations that were developed, as well as serving on major committees at ISO, at RESNA, and serving in advisory roles on global activities. And that includes the CLASP Product Advisory Committee that is basically they adopted a strategy that we recommended to review their products before they would put them in their catalog. And a similar approach, we've provided a lot of advice to UNICEF for their solicitation, and then also helped launch a test lab in India. So we've had a great run of success, and that sort of what I just listed does not include what we talk about honestly on these meetings, right? Which is providing direct guidance to test labs and to wheelchair designers on how to improve their products. So what I see is obviously just the global experts on wheelchair product quality on this meeting, and an opportunity to keep on driving the product standards forward. And how we do that is, I think over the next year, we want to consider the format of this meeting, the activities that we are doing in ISWP, and provide that support to Alex and the board in terms of developing a strategy to drive product quality further ahead. This, I would say, is not as easy to map out as training service providers. That is a tough job, but I think we understand how to do that in a very systematic way. Product standards has many different levels that you can have an influence. You need to be a consulting body where people propose designs and we provide advice, and we've been part of that. But we also need to provide some fundamental guidance to governments, to ISO, to CLASP, and to AT-Scale, who are the ones implementing a lot of these standards. And sometimes they're doing it great and it's working really well. And sometimes we still see, a large number of, products that are of poor quality that are getting to the consumer. So I think, I'll leave it at that in terms of just saying I think it's important for us to look at what we've done and work with the board and with Alex on developing strategy for how to move that forward. I'll say that one of the great collaborations that we initiated, I think, a couple of years ago when AT-Scale started, just being part of that discussion with AT-Scale, that relationship has grown very strong. And we co-hosted an event in Geneva late last year with AT-Scale to talk about product standards as one of the key areas that they're also focused on. They're a major funder in the wheelchair sector now. They have pooled funding. They essentially operate as a pooled funding mechanism where different agencies provide them money, and then they pool that money to try to do larger projects, multi-country projects. Part of their goal is to advance product standards and is to advance competitive types of dynamics within a market. So you're not only just forcing companies to live by a certain product standard, they are trying to develop sort of market-driven approaches to have low-cost products that are highly reliable. So they're the ones that are purchased in a country. And we are the group that can help guide that. I think there's probably a few people I would add to this meeting, but you all have the expertise, have the knowledge about the products, understand about purchasing policies, and can drive that. And I think that's where, I think we need to start looking at that from a strategic standpoint about how to provide guidance to governments. In some cases, that's direct consulting, but in other cases, it's developing guidance documents that they can learn about how to go about the purchasing process, about establishing product standards, testing to those product standards. So I see that as a major opportunity and a critically important opportunity, because in spite of all the work that we've all done to try to drive up product quality, the data from the field doesn't say that products are reliable. There's still a lot of problems out in the field, and that's the data we have to live by. So there's still a lot of work to be done here, and I appreciate everybody's commitment. This is a voluntary effort, it's been that way for 5-6 years. But I do see a lot of important role for us moving forward. And I think that'll be part of the discussion as the new board gets set up and as Alex sort of works through all the different work streams that ISWP has been involved in. So those are my few words that stretched very long. And so I appreciate everybody, and I think I'll give it back to Steph to move to the next agenda item.
Thank you both. I just want to highlight again what both of you have mentioned, and especially thank all our members, because all of your input has been very valuable on evolving efforts for this. So before we move into our next topic, I just wanted to mention, I know that as part of our last meeting, we were trying to find a way on how to do the certification through the proficiency process. I just have to say that I've been looking a lot into an expert who would be able to explain to the group how to do this. Unfortunately, I haven't been able to find one who would be able to explain this so far. So I'm going to continue to look, because I think that it would be really important to convey appropriately the information that would be useful for other centers as well. So I just wanted to mention that before we move to our next topic. And Jack, you're up next. If you would like to share your screen, please feel free to do so. I can stop mine.
I can probably just, if you don't mind, Stephanie, I can probably talk over this. I don't have anything to really show, but I can give some updates just in terms of kind of the direction we're going in terms of caster testing studies, and also just kind of the work that's coming out of, what we've been doing. So for people who have been on, since I kind of started doing my master's work, one of the things we really looked at was, large data, failure sets, of really looking at the trends of how casters are failing in the community. And on, we had a lot of findings from that, but one of that was actually a potential in the effects of preventative maintenance on the lifespan of components, especially casters. So we really started looking more into, can we prevent failures from happening through, regular checkups and routine replacements of components to kind of extend the life of casters. So this is kind of something that has formed two different things. One, a study that we want to do, which is, can you simulate the effects of preventative maintenance in the laboratory? So basically an upcoming study we're going to be doing is actually testing the standard casters that we use in, most of our testing. And while they're on the durability part of the testing, actually stopping them at significant time points in the testing and actually replacing components like the bearings and the bushings to see if that will actually extend the life of the caster samples. We know this caster fails a little under 2 years if you just let it run from testing these multiple, having a pretty large data set of this. So we basically want to see if you can replace these components, especially bearings, and see if that extends the life. The hypothesis being that it will, but being able to simulate this in the laboratory is going to be really useful, because another part of this is what we're doing is kind of forming a best practice in terms of repair and preventive maintenance, in terms of what manufacturers should have listed in their manuals, in terms of what is expected in terms of repair and maintenance. All these different things that we have been putting together for maybe, since the beginning of the fall. And we have a solid draft of it. We want to basically debut it at the International Seating Symposium, which will then open up to open comment to be able to give us feedback on what we've outlined and what we've come up with. So this study kind of goes hand in hand in us trying to show that preventive maintenance is a practice that should be adopted within the field, because it can, extend the lifetime of components. So this study will be a really nice way to see how that's demonstrated in the laboratory, essentially. So, yeah, I mean, that's the biggest thing we're working on now, but it should, produce a lot of findings and, come up with a lot of good output that should be good for the field. So.
Thank you, Jack. And I know that you have met with other testing centers as well. I think it was Tom from DECA who you have been working on. So I'm glad that this is an ongoing progress as well. And I don't know if you guys have any questions for Jack. No? Okay, then our next topic is going to be Daniel Umaña from CIREC in Colombia. Daniel, please feel free to share your screen. I want to introduce everyone to Daniel. He works in Colombia, but feel free to introduce yourself to the group. I'm sure that everyone wants to know more about you.
Thank you, Stephanie. So yeah, I'm an industrial designer and a CPO from Bogota, Colombia. I'm working right now on developing wheelchairs, wheelchair frames. So we've been doing some testing. More likely, like we're trying to test the production process more than the design itself. So we're trying to find out how can we make these wheelchairs in Colombia. I don't know if you can see my screen. Am I sharing?
Yes, we can see the presentation.
Okay, so I work for CIREC, which is a nonprofit foundation that invests its efforts in rehabilitation. So we have orthotics, prosthetics, and wheelchair service. And we're trying to build the new area, which is going to be the manufacturer of wheelchairs. So we're not going to make all the parts and accessories, but we're just going to be focused on frame building, custom size and frame building. So I've been working like almost 20 years developing steel products. I used to work with bicycles, welding and designing bicycles. And then I studied orthotics and prosthetics, and I started developing these type of products for CIREC. I'm working right now with sports and some prosthetics, and right now I'm in charge of the whole production line for the wheelchairs. I work as a production manager here, so I'm trying to develop new processes for the orthotics and prosthetics. We're working with 3D design and 3D printing and milling for the prosthetics, as well as all the 3D design and manufacturing of frames. So in Colombia, we have a very varied climate. So we have from sea level to what we call here paramos. I don't know if you know, it's a really high, I don't know how, Stephanie, if you can help me, paramos, I don't know how you translate.
It's hard to describe, but basically it's like very high in the mountains. It's very cold and it's kind of dry. So the description of the conditions would be like you typically have a lot of grass that has grown a lot with a mix of wheat, that kind of texture. So it tends to be difficult, and even for the conditions on the skin of the people can be a little bit rough because of the coldness. So
so we have like all the climates you can imagine. So we have from 24 to 35 degrees Celsius up to the really high mountains. In CIREC, we provide from active wheelchairs to tilting wheelchairs. And we work with the free wheelchair mission, and we provide those blue wheelchairs you've all seen, I'm sure. So we're trying to make a hybrid between the free wheelchair mission wheelchair and an active wheelchair. If you can see on the top image, this is Bogota. We have not the best, we don't have the best sidewalks, and there's not much infrastructure for the wheelchairs. So people are tending to share the way with share the road with the other vehicles. In the more rural areas, we have basically no roads, and in some places not even sidewalks. So we have to work around and develop designs and the configuration of the wheelchair so that they're appropriate for all these type of environments. So we've developed like I've separated into 3 phases what we're doing right now. The first phase is like the wheelchair design, which is basically how to take those patient measurements, if it's tapered, non-tapered, the design itself, if it's going to be 4 wheels or 3 wheels. A second one, which is wheelchair fabrication. So identify which kind of machines I'm going to be needing for the machining, the welding, and painting. And the third one will be the wheelchair testing, which we've only done alignment testing and center of gravity testing. So the first device I'm going to show you is the wheelchair measuring device, which I'm designing. The second thing I'm going to be showing you is how we identified the industrial process to manufacture those wheelchairs. We did 2 prototypes, steel prototypes, handmade. As I told you, I used to work in the bicycle industry, so I have some experience, and I've made this like handmade wheelchairs using steel, just to prove to my boss, like, we can do this without technology. What could we do if we have the technology that it's needed? So we're also developing the production line and the possible machining solutions. We've designed a welding jig, and I'll show you in the end the hybrid wheelchair design that we're working on. So this is the first design we made for the wheelchair measuring guide. We've had a lot of problems. In Colombia, there's not so many places where you can go and get those measurements taken, and there's been a lot of mistakes. So we're trying to develop a product that can minimize the amount of error while taking those measurements. This is a basic design which can tilt and which can basically fit the user, and then we can take the measurements using those like boards you see here. So we can change the width and take the measurement on a straight line. So we've had a lot of problems, as I told you, with the measurements. Sometimes people say like add 2 inches, add an inch. It's not really standard. So that's the purpose of this product. This is the second prototype we're trying to work on, a lot simpler without the tilting possibility. But again, trying to get those like flat zones so we can take the measurement flat to flat without using any other aid. And that way we can take a more precise measurement. This is what we're trying to work on. So our design is simple right now, just trying to focus on how to build those designs and which machines we're going to need to buy to be able to produce this wheelchair frames. So the basic thing is like bending those tubes, bending the frame. How to build that pin or control mechanism has been a really hard part. The center of gravity, how can we change that center of gravity without making that wheelchair really long? So that's been another challenge. The wheelchair height, which will determine that tilt, has also been a challenge, and the caster tube bending and metering of the tubes was another challenge we experienced. So as you see, it's a basic design. I'll show you some of the prototypes we've made. We've also made this, like, I call it a folding lock, so we can fold the backrest and make that wheelchair like easier to transport. This is our pin design. So we had a lot of problems making that pin and making it work. And our boss is telling us, try to build it yourself so we don't have to buy as many accessories. So we're trying to design and build the pin ourselves. So it's a basic pin just to control the backrest. This was a prototype we were working on for the footrest. So basically having that tibial tarsal alignment as well. and the basic wheelchair that we're working on. Trying to separate each piece that we're going to need to build. How many screws, how many pins, how many, like the amount of tubing we need for the testing. And by testing, I mean the testing of the welding process. So separating everything and trying to get every piece. As you see, I work by hand. So cutting all these tubes, we use steel because it's really hard to get aluminum in Colombia. We don't have any aluminum here. So, but we have a lot of steel. So we're working on those prototypes using steel. And if you know, the free wheelchair mission uses steel as well. So we're trying to use this as long as we can, so that when we can buy the aluminum piece, we can translate this fabrication process into the aluminum. This is the bending machine we've used. It's not high tech, it's really low tech, but we've used it to bend the tubes. And by using this, we realized we needed more technology and we needed a better bender so that we wouldn't generate wrinkles in the frame. And we've developed a system using this machine to bend the tubes where it's been welded. You know, steel tubes are welded on the top. So that weld we've placed in facing the inside of this cylinder, so that when it's bent, the weld of the tube, it's inside, and that won't generate wrinkles. We've also cut these using laser cutting machines, those locks that are going to control the backrest bending, folding, sorry. And we've used MIG welding to build our frames. As you can see here, there's a point where it's being pressed. So the tube is kind of wrinkling around. It's not properly bent. And that's something that we've been working on, trying to find which bending service is better, because we don't have a bender here. So we have to work around whatever we have available. The taper design, it was the first design we worked with, because it had a lot of bend in the tube. So we were working with that one first so that our boss could see how complicated the process really was. If you see, these ones are the ones that are going to hold the caster wheel and the bearings. Those we had to weld and lathe. I welded an inside, like I put a tube inside, and then I braced it. And then I took it into the lathe and reduced the inner diameter so I could fit the bearings. Again, all this is done by hand. We're working on that pin design. This is the first pin we tried to build, which didn't work because it didn't carry enough strength so that when you were leaning on the backrest, it just popped out. So we have to work on the design. We've also tried different types of welding. This is brace on the backrest. This is the welding of the pins, like housing. So the pin's gonna go inside this housing, and that was welded using brace, like the same bracing process. Then we had to work around the seating and the locking mechanism for the seat. That's an aluminum piece we got. There's some aluminum you can get in Colombia's, but you can't get every type of alloy. So just working with the alloys we have available. So I welded these brace-ons. These are screws that are braced on to the frame. So I can, if you see there, they already have the, I don't know how you call it, the rosca, la rosca de la tuerca, Stephanie. I don't know if you can help me. So
¿La rosca de qué?
De la tuerca, de las tuercas, como
The
un
nut.
tornillo. Okay, so I had to weld those. And if you see trying to make the holes on the frame was quite difficult. We have to work on a jig so that we can keep it straight. It's not really straight. So that's something we have to work around and build jigs so that those holes are straight. Then I weighted the frame, the complete frame. It's more or less 29 complete. Then we took it to the paint. We had a lot of problems with the painting process because we tried to like sand those welds, and then we used the plaster they use for cars to like hide that weld. And when we painted, that thing like popped out and the paint got all messed up, so we had to do it again. And painting is something that we want to do as well, so it's been a like trial and error trying to find the powder paint for the steel frames. Here you have the locking mechanism and those 3 positions, with the 4th position completely bent when the backrest is completely bent forward. Another thing we had to work around was the height of the wheelchair. The first wheelchairs, we were sitting on top of the wheel. If you see, it's really high. So we cut this one and we tried to reduce the height so that it's like on the bicycles, when you talk about rider compartment, you're contained in between those 2 back wheels and not sitting on top of the wheels. These are the 2 prototypes we built. So I mean models. So we could test different things with those models. One with the tapered front and one with a straight front. Another one with a curved, how do you call it, a caster arm, and one with a straight arm. So then we can compare how those 2 behave. This is what we're trying to work around, how to get the metering process. So I have a software that gives me this like template. So with this template, I can cut the template in paper and then paste it on the tubes, and then we have a complete contact between the tubes, so that then we can weld, and it's not gonna be like tube weld tube, but the tubes are gonna bend together. I mean, they're gonna fuse together. So this metering process has been really hard. This is a machine that we're trying to buy from Bailey in the US. This works with abrasive metering. So it's really interesting because we just have to change this cylinder to match the outside diameter of the tubes. This is the welding jig I'm designing, so that we have 2 different positions for welding, one with the frame upside down and one with the frame completely, I mean, straightforward. And it's we have a control for the height, a control for the width, and the control for the caster. We call them bottles here, but for the caster, I don't know, cylinders. This way we can guarantee the alignment, which was a thing we proved, because I welded the frame, but I welded it without a jig, so that when we put together the wheelchair and I pushed it, it just tended to roll to the side. So the jig is really important, and it's something I'm working on the whole design, so that we can, the next frames we build are going to be built on a jig, so that we can guarantee the correct alignment of the frame. We've also worked on the WPS for the welding standard. That's something we have to define with the tubing, because we're trying to get Chinese aluminum, right? So it's 6061 and 7003. Those 2 different types of aluminum, we're going to have a different type of WPS for each. That we have to work on when we get the pipes, because right now I'm working with steel. Now, regarding the design, I've worked with these type of designs where you have the pelvis like lodged into the straight part of the frame. And as I told you, we have the tapered and non-tapered wheelchair. This was the first design we tried to build. The thing about the backrest was another complication, because when I was talking to Sarah, she said, like, it's better if you're gonna provide a wheelchair that people can like replace parts easily and do the maintenance themselves. Then it's better if you don't have a very complicated backrest. So we worked around like the type of backrest you see with the free wheelchair mission wheelchairs. Here you have the first prototype that we built. And this is the one we're working on right now. So we have that like strange frame and I don't know how you call tensión regulable, regulable
Adjustable tension.
adjustable tension backrest and seat. That's the one we're working on right now. So I'm going to show you if I have the frames here. Yeah, so we're working on, we used this aluminum pieces from bicycles to provide that space and that control for the footrest. We have a very large bicycle industry here, so we're using parts from the bicycle industry for the wheelchair. The wheelchair is really light. I mean, it's steel, but it's still a light wheelchair. The thing about the backrest, well, how are we going to provide a backrest that's not going to, I mean, this one totally pulls out. You have to work around it. The welds were really good, but still we have to work around it and provide better welding. We also work with this type of backrests, which are really cheap, but not very good. Yes, so we have to design something that is easy to fix, but that's going to provide a better support. And for the non-tilted wheelchair, non-tapered, we've also worked with the footrest, so with that one we can, I don't know if you call it tibial tarsal movement, but providing that possibility. As you can see, the height of the wheelchair can be adjusted using those aluminum parts from bicycles. And we provided 3 different positions so we could make it shorter or longer. I haven't been able to get the caster, so what I did was when I welded this is like the same thing, la puerca. When I welded it, I took the welding machine and gave it 2 degrees angle, so I wouldn't have to use a caster, camber, expensive piece. It's just a la puerca welded inside.
The nut is welded inside.
The nut, yeah, it's welded inside, and it has a 2-degree angle, so we wouldn't have to buy expensive pieces. Because we're relying, basically, all the parts and accessories are going to be imported. So if we can reduce the amount of pieces we have to import, that'll be a lot better. Yeah, that's another thing. Try to convince my boss to not depend so much on the import products for parts and accessories, because we don't have any fabrication in Colombia. So we have to bring everything from the wheels to the screws. So if we can reduce the amount of parts we have to buy, it's going to be better. Thinking about like that hybrid between an active wheelchair and the free wheelchair mission wheelchair. So I know it's not that technical right now. what I've been doing so far is like trying to work around how to build a wheelchair, how to provide a cheap, I mean, not cheap, but an affordable wheelchair for the National Health Service. And once we work around all the steel wheelchair products, we can start working with the aluminum products. But first we have to develop a system to produce these wheelchairs and then move on to the better materials and the more expensive aluminum tubes. Yeah, so that's what I have so far.
Thank you for sharing this, Daniel. I think it's very interesting that now that you're evolving with different materials and also like the way that you are exploring how to put them together. And I do want to invite the other members in the group. I know that some of you are part of manufacturers or that you have been testing different wheelchairs. Is there any recommendations that you would be able to provide for Daniel as part of his product development?
This is Don from Free Wheelchair Mission. Daniel, you're doing a fantastic job. Unbelievable. The rigor that you've got from the design with the wood and the modeling to the fabrication. And I know how hard it is to manufacture something in countries like Colombia and get parts. So, boy, I'm blown away with your progress. Fantastic.
Yeah, I'll echo what Don just said, is that, the level of detail you're going into is excellent. And it's wonderful to see what you've been able to accomplish. I think obviously if there's some comments, then we should, bring them forward right now on the call. But one thing I'll mention that we don't use very often is that, the email list that we're all part of. I think we can offer suggestions through that. We can also, feel free to reach out directly to him to provide advice and partnership on whatever we can support for this work in Colombia.
And Daniel, I am completely familiar with the lack of materials and resources. So when I went to Ecuador a few months ago, well, almost a year now, I was looking into different casters, and I found there's a big lack of options, basically. Like they're not really familiar with wheelchair-related accessories in this case. And not only that, but also like the quick release for the wheel, the rear wheel. How are you guys dealing with those two pieces?
So as I was telling you, we are only being able to import those pieces from China. So what I've been doing is I go into madeinchina.com and then I start talking to the providers, like, can you get these cheaper ones sent to Colombia? So I've managed to get like around 100 pins for the quick release pin. They've charged $5 for each. So it's not that expensive. It's not the best quality, but we've been able to work around, and I've been fitting them to the wheelchairs we are providing, and they've worked great so far. I mean, I haven't had a problem. The caster wheels, then again, I'm importing. I go into Made in China. Hello, I'm Daniel from Bogota, Colombia. I need this type of caster wheels. Can you send them through DHL? I'll get the service paid, and we receive those, and then we test them. The hardest part for us was like welding without the jig, and when it doesn't matter what type of caster I get, if we have no jig, that thing is the wheelchair is gonna just roll to a side. As I was pushing it with like it was 50 kilograms, and I pushed it, and it just tend to go to a side because it's not completely straight. The casters, again, we're talking to some providers and then to suppliers. The suppliers send the casters we ask for. We tried two different kinds, the single arm caster and with the two arms. And we didn't have any like issues with either one, but the vibration popped the the one with the single arm, if we submit it to a lot of vibration, that one tends to like get loose really fast. I mean, it wasn't 3 kilometers and it was already loose. So then we have to think about, can we build those things in Colombia? Can we get the machining process done in Colombia and bending, and will it work? Because we don't have the correct alloys. So if we have some aluminum alloy that it's not going to be the proper one, then I'm going to submit that. I mean, it's going to be risky. And we don't have the testing center yet. I mean, that's something I've been working on. I took the basic course with the ISWP and I have all the machine plans. So I'm trying to get resources from my boss so that we can build those machines and really test them. Not just like pushing it around or giving it to a user, because I can't give it to a user without him signing the release and it being a lot more risky. So we've been working just with weights.
Thank you. I want to open up for additional questions from the group. Okay, so thank you so much for sharing this, Danielle. I think it was really interesting to learn all your progress and it looks really amazing. I hope that if you have any questions, we can always follow up through our distribution list. So I just want to make sure that you always have like someone to reach out to. I know that a lot of people in this group are very knowledgeable and will be interested in responding to you. I just want to continue now with our next presenter, who is Nargess. Nargess, if you want to jump in, feel free to share your screen, or Amir, I know that you guys are here. This group is from Germany. They are part of PAConsult. This is a new group who is being part of our testing centers. They're gonna be explaining a little bit more about what they do, but I just, as an introduction, they have been a testing center for medical equipment or medical devices, and now they are starting to add wheelchair testing to their facilities. So please feel free to share what you need to share with us, Amir or Nargess.
So can you hear us now?
Yeah, we can hear you now.
Actually, we don't have a good quality of sound, and I have trouble connecting with my own computer. Please. Can I check once more?
Yeah.
Yeah, okay. Can I directly share the screen, or I have to send the file to you?
You can share your screen. If you
Okay.
want, you can send it to me and I'll help if the connection is not great, but it's up to you, whatever you prefer.
Actually, because the PowerPoint presentation that I have prepared contains some videos, it has a huge size. It's about 500 megabytes, I can say, and it will take so much time if I want to share. So I prefer to directly go to the presentation here, sharing the screen. Can you see my presentation now?
Yep, we can see PowerPoint now.
Great. Okay, hello everyone. I'm Nargess, and now I'm presenting with my colleague's account, Amir, here beside me. We are presenting PAConsult, not PAConsult, PAConsult from Germany. And actually our main field of work is not medical devices, but is environmental testing and package testing. But we want to head into a new area or field, which is medical device testing, and we want to start with wheelchairs. And Due to some reasons, we decided to start with manual ones because we found it more relevant to the devices and machines that we already have. But I want to introduce you to the labs we have and all the works that we do here, first of all, and this might help you to have a better understanding of our daily works here, and then you can help us in finding the best solution of the test methods, the standards that suits us the most. So here I start. First of all, I want to say Happy International Women's Day. Today is 8th of March, and I hope that every woman in the world who are collaborating to the evaluation of science and every woman have a happy day today. And then I will start with presenting our labs at PAConsult. As a test laboratory accredited to ISO 17025, PAConsult simulate different environmental situations. We have 5 laboratories across Germany and Switzerland, and each lab is specialized in a certain area. And you can see here in the image on the right side that each PAConsult branch has its own special name due to their specialization. Our company has over 22 years of experience in the implementation of projects in the aviation and shipping, medical technology, automotive and railway industries, security, electronics, etc. However, we create individually tailored solutions for an extremely diverse range of products, preparing the product for fitting the market. Our laboratory is located in Hamburg, and now we are talking to you from Hamburg, and our department is divided in 2 sections. One is medical testing, and by medical testing, we mean package of medical tests, package of medical products, and transport simulation. In general, in general, the transport simulation in PAConsult consists of vibration tests, shock tests, shake tests, drop tests, and compression tests for all packaging types, and the inclined plane for pallets. Low air pressure test is also sometimes requested by our clients due to some standards.
Now we'd like to show you a video that we took from our testing laboratory here in Hamburg, in the Humboldtstraße that we are. So let me just start the video. So I don't know if you had any sound, there were just some background music, but let me just move on.
Okay. Can you hear me now?
Yes, we can hear you.
Okay. As you might seen in the video, it was an overall, it was like a preview to the daily tasks we have in our lab in Humboldtstraße. One of the tests that we do is the transport simulation, and it consists of different parts, starting with vibration shock tests. In overall, we have about 15 different test systems for vibration and shock tests, which cover a wide range of frequencies of up to 3000 Hertz. The test devices differ in the characteristics of force vector, amplitude, and frequency range. Both electrodynamic, servohydraulic, and pneumatic test systems are available in our laboratories for the mechanical tests. Our vibration tables for shaking tests are also used, and they are focused on the resistance of the cardboard boxes and upholstery. These shaking tables or vibration tables cause damage patterns such as abrasion or general material fatigue of the packaging materials externally. In contrary to our shakers, our vibration tables can run tests in very low and a limited range of up to 5 Hertz. Delivery boxes can meet incorrect handling during their transport processes or by delivery staffs like UPS, DHL, Amazon, etc. Therefore, a series of drop tests are defined on some edges, faces, and corners as explained by the standards, and they can simulate this mishandling. We have 2 different dropping systems: an automated drop test, which is used for smaller objects which with their mass of up to 100 kilogram, and a drop hook for heavier objects of up to 250 kilograms. And in most cases, we use them for the pallets. The packaging is stressed either by short-term or long-term loads, as can occur in storage, and it's usually in a vertical orientation. Automated testing with constant load and continuous load increase on packaging systems. To simulate mechanical shocks on transport pallets, the inclined planes are used because we believe that this can be caused by heavy delays on a loading area and during mishandling with industrial trucks. A high-performance vacuum chamber is available to simulate the requirements for air transport, and the pressure range in these chambers is about 25 up to 2000 millibar and only available for smaller packages and for samples. By means of a laboratory simulation, actually, let me first mention this, that PAConsult has climate chambers of various sizes in which extreme temperature, humidity, rapid temperature fluctuations, condensation, and icing can be simulated. Climate chambers are applicable for reproducible investigations into the suitability of the products to climate and weather relevant criteria. Let me open this in more details. Most of the times, but not always, before any mechanical testing or transport simulation, there is atmospheric preconditioning. According to the standard or the client's preference, the samples are stored at various combination of temperatures and humidity profiles, or even in the laboratory ambience, for a specific duration before starting the test. The combination of temperatures and humidity profiles can simulate different geographical sites that the package is planning to experiment during its journey to its final destination. These profiles can go as high as 180 Celsius degrees and 98% of humidity, and as low as minus 70 degrees and 10% of humidity. Actually, the 10% of humidity is very hard for the chamber to perform, but we also run that. At some cases, the package or pallet needs to be stored in room temperature, for which we possess a constant climate room of 23 Celsius degrees. That usually medical products are stored there, and their unpacking process is also done in that same room. In general, we have over 20 climate chambers or cabinets in various sizes in PAConsult. Moreover, for pharma industry, there are some the shelf life of medical products are highly important, and therefore there are some accelerated aging chambers required that we also have them to receive data on the approval of the product at any early stage. These tests within our accelerated aging cabins are performed, which simulates the shelf life of the product in a much shorter time. For instance, 90 days of chamber at 55 degrees will simulate about 5 years of real shelf life. I thought this might be too much information, so I want you to have a journey to an ordinary life of a package with us in the PAConsult. By means of a laboratory simulation, the shipping unit, usually containing medical devices, but not always, are tested to transport stress here. The transport simulation is performed according to the specification of the client, which defines the standards they want and the parameters they want, or by the standards directly, but more commonly based on various ASTM and ISTA standards. In our nomenclature system, the test items are referred to as EUTs, which stands for equipment under test. The dimension of the EUTs are determined by measuring from edge to edge, by a calibrated measuring tape, and the weight is determined by using a calibrated scale. The incoming goods are controlled for any visible damages at the packages before going through the test. The test equipment that are used in the laboratory of PAConsult all should be listed in the report, as well as the working hours spent on the project and calculated in the offer. Also, the test procedure is described in our final reports. After the preconditioning that I mentioned before, the transport simulation will start. The first step is the mechanical handling. For the single packaging testing, the drop tester is used, and for the pallets, the hook drop test is applicable, which we call the rotational flat drop. You can see on the left. Next, the side impact is performed in the middle at a pre-calculated velocity and on specific faces of the pallet. After mechanical handling comes the vehicle vibration with our shakers. The profiles used in this step that you can see in the left are usually predefined and simulate vibrations on the packages during the delivery by a truck or means of air transport. Next step is warehouse compression simulation by our compression tester. For the stacking test, each shipping unit is positioned in the middle of the compression tester and is compressed until the required test load is accomplished. For some tests, the durability of packaging and the cardboard tapes should be tested by a concentrated and accelerated impact to evaluate the resistance of the packaging against sharp impacts. We call them concentrated impacts. Both ASTM and ISTA have defined an impact test using a very specific steel projectile, which is released on the package at its specific faces and from specific height. The test result is a pass or fail determination based on acceptance criteria previously established. Usually after the test, the shipping units are not opened in our department, but in some departments they are opened. And the final visual inspection of the content and evaluation of the result is performed by the client. Nevertheless, any visible changes from the smallest wrinkles to deformation and ruptures that has occurred during the test should be reported. Also, you can see one of our climate chambers on the right side. I already talked about accelerated aging, but after transport simulation, some packages are opened in our department for medical testing. And as I mentioned earlier, by medical testing, we mean the package of medical products. In this regard, first, the SBS or sterile barrier systems are visually inspected for any damage or sign of non-sterility due to the transport simulation. Shelf life validation is really important, and the sterile barrier system must maintain the sterility in the final packaging until the time of use. So to ensure this, the integrity and the sealing force must be checked over the duration of a specified shelf life. We also use here the tensile test for the packages of, or for the SBSs. For the dye test, this is the test that two colleagues of mine are doing with a dye solution in the middle picture, and the bubble test in the lower picture on the right, which can determine the smallest damage caused by storage, transport, or the selection of unsuitable packaging. Actually, our labs are accredited for a huge range of international standards, including but not limited to the following list of standards that you can see. But if you want to see them all, please refer to our website because I know that it's not readable here. Okay. Our labs are accredited to ISO 17025, but we have other certifications, including DAX, which is specifically for the German accreditation, ISTA, Airbus, and Amazon FFP. This part of my presentation goes to the other labs and fields that PAConsult is actively working in. However, I only chose those quite relevant to wheelchair testing, while most of them are beyond my knowledge, so I only mentioned them quickly. The area of environmental simulation is beyond the transport simulation and mainly consists of engineering testing and prototyping. And some of those tests are mentioned here. However, two of the tests that I found maybe is relevant to the wheelchair testing is like salt spray corrosion test, which I found was mentioned in ISO 7176 part 32. So we already provide that test, and also we have IP class test, which is ingression protection class, which defines the degree of protection of packaging, casing, or enclosure against water or fire emitters. I don't know if this can be relevant to wheelchair testing, but these are the tests that we already have them in our PAConsult. Also, PAConsult Synapse, our branch in Berlin, provides various lists of tests, including rocket testing, but their main focus is battery testing. This can be relevant to power wheelchairs if we are going to add them to our list of services in the future. We already have another video, which the description of, the abstract of the descriptions that I had to you is provided in that video, is summarized in that video, but please let me know if you can hear the sound, otherwise we have to skip it.
Just make sure that the sound is here. I'm gonna take a
Nargess and Amir, I'm sorry, but would it be okay if we skip the video? I know that we're running out of time.
Of
So
course.
if we would be able to go to the questions that you guys had about the wheelchair testing before we jump into our next presenter. Sorry, I'm just trying to keep track of time.
It's totally fine. Thank you, Stefan, for mentioning that. It's totally fine.
Thank you very much.
And sorry that we don't have any video for our Zoom call because our desktops in our labs are not equipped with webcams, so we only have the voice. Sorry.
It's okay, don't worry.
Thank you. Okay, so now we want to hear from experts that with the machines, devices, and services that we have, what would be your suggestion for our first step toward wheelchair testing?
And I believe you said it's going to be for manual wheelchair testing for now, right?
Actually, hello?
Yep, we hear you.
Actually, our initial aim was that to find some applications for our vibration table and the shakers, maybe use it instead of drum test for the fatigue test. But we heard from another expert that this might be used for the power wheelchairs, but not for the manual ones. So our initial aim is to find the suitable application for the devices we already have. It's not important if it's manual or power ones. So anything that is more relevant to the devices that we already have is welcome at the beginning. Then we can proceed to the other type of wheelchairs.
So Bill, sorry to put you in the spot, but I know that you have been testing both manual and power. Also, as Stephen Peters is here, do you guys have any specific suggestions on this?
Well, I think it's important to note that although I really like their lab and it looks like they're well equipped, it just doesn't seem to me that any of their equipment really applies to the current wheelchair standards. Even their ability to shake something, none of that is in the current standards. That's not to say that it couldn't be in the future, but I really think that you should probably take a good hard look at the 7176 series of ISO standards and take a look at the equipment that's in those. The way the standards are written, it's not like you can adapt other equipment and modify tests and still be compliant with what's in the test standards. So, you know, for instance, in our durability testing in 7176, section 8, you know, we have a multi-drum test and drop test, but I don't see how you could do those tests on any of the equipment that you showed us. I hate to be negative here with you on your first visit here, but I think it's maybe important that you take a closer look at the 7176 test series and then see what you're getting into first.
Thank you, Bill. Actually, we already reviewed part 8, and based on that, we wanted to change not the standard, but the method of doing the drum test. Maybe we actually our workshop manager had some ideas about using like treadmill instead of a drum test, or maybe using or programming our vibration tables for specific profiles of replacing the drum test, but I think it's not doable, right?
Well, I think you just said that that's not doable. I would agree with you on that. The problem is that you would have no way to verify that what you're doing is as effective or more effective or less effective than the drum test.
Mm-hmm.
So you just can't substitute another type of test for something in the standard and say that you've satisfied that standard. It would take an awful lot of work on your part you would have to do comparative tests on your equipment and the drum test to determine whether or not your results were in line with what occurs. We've had people propose a treadmill type test in the past, but it became too difficult to monitor, and it was actually more difficult to set up a treadmill type test than it was a drum test. So, you know, if you want to go that route, I would think that you would have a long road ahead of you, as opposed to just building the equipment that's currently in the standards and using it.
I see, thank you. Actually, we had another recommendation to use ISO 7176 Part 2, which involves driving power chairs and scooters on fixed or adjustable incline test planes at full speed. Do you think that will be suitable for our inclined impact test or not?
How big is your ramp?
You mean how long is it?
Yeah.
About 2 meters. So it should be small.
No, that's not long enough. You have to be able to get the device up to full speed. 2 meters is not enough. It's if you look in the standard, it's suggested that the meter at a minimum is 3 meters wide and 10 meters long.
I see.
You could use your short ramp for static stability, which is 7176 section 1 for static stability. The ramp that you have would be suitable for that because the wheelchair doesn't have to move. But if you're looking at dynamic stability 7176-2, then you need to have a place where the wheelchair can get up to full speed in order to do the test properly.
I see. Thank you.
I would just add another thank you for your manual for the testing dummy.
Oh, you're welcome.
I fulfilling it. So I'm working in a workshop, and it was really helpful. I didn't know how to do it myself, so thank you very much for that.
You're welcome.
Okay, so the summary of your saying is that we don't have anything suitable right now, and we have to adjust at least some of our machines or buy or create new ones.
I think we're already on that journey to building new stuff.
Do you think, Bill, it might be wise for the good people here to join their national standards body, DIN, and the relevant committees that deal with medical devices?
Oh, certainly.
Yeah,
I would appreciate the help.
yeah.
So I think what Bob is suggesting here, Amir, is that possibly you could become involved in the ISO standards, developing those. I'm the chairman of the ISO SC1, I'm sorry, TC173 SC1 WG1 wheelchair standards group. There's also a wheelchair standards group for the powered wheelchairs. That's a WG10. And participating in those, you would be finding a lot of information, and you would also expand your contact base to people who are in the test industry.
Yeah, and that would need to be through the national standards body. It's not just a matter of rocking up at an ISO meeting. You'd need to be nominated by your national standards body, which is DIN. And I think that it would be it's not an overnight process getting familiar with all of the tests and test methods.
No, it's not.
It takes some time. How long, Bill? The first 5 years is the worst, isn't it? Really?
Yes, it does take a long time.
Yeah.
I've been doing it 25 years, and I still open the book every time I do tests. So.
Still learning, yeah. Oh dear.
Well, thank you everyone for staying a little bit longer. I know that we are about 4 minutes past our time. I was texting internally with Tom. Since we are out of time, we're going to continue with his presentation in our next meeting. And Nargess and Amir, I think that we can also continue this discussion in our next meeting for sure. But I appreciate everyone's time for staying a little bit longer and looking forward to seeing you in June. Okay, so happy International Women's Day again, and I hope you have a wonderful rest of your week. Thank you.
Bye-bye.
Thank you.
Bye.
Bye.
Thank you.
Bye.
Bye.